This is Openstax Contemporary Mathematics, Chapter 3, Section 4, Part 2. Excuse me. Example 359. Subtracting rational numbers with unequal denominators. Calculate 14/25 minus 9/70. Solution. The denominators of the fractions are 25 and 70, so we label b equals 25 and d equals 70. Step 1. Find LCM 2570. This is 350. Step 2. Calculate n and m. n equals 350 over 25 equals 14, and m equals 350 over 70 equals 5. Step 3. Multiplying the numerator and denominator of 14/25 by n equals 14 yields 14 times 14 divided by 25 times 14. 14's cancel. 196 3/50. Step 4. Multiplying the numerator and denominator of 9/70 by m equals 5 yields 9 times 5 over 70 times 5 equals 45 3/50. Step 5. Now we subtract the value from step 4 from the value in step 3. Oops. Hold on one sec. So we get 196 over 350 minus 45 over 350 equals 151 over 350. This is in lowest terms, so we have found that 14/25 minus 9/70 equals 151 3/50. Your turn, 359. Calculate 10/99 minus 17 300. Video. Adding and subtracting fractions with different denominators. Converting between improper fractions and mixed numbers. One way to visualize a fraction is as parts of a whole, as in 5/12 of a pizza. But when the numerator is larger than the denominator, as in 23/12, then the idea of parts of a whole seems not to make sense. Such a fraction is an improper fraction. That kind of fraction could be written as an integer plus a fraction, which is a mixed number. A fraction, 23/12, rewritten as a mixed number, would be 1 and 11/12. Arithmetically, 1 and 11/12 is equivalent to 1 plus 11/12, which is read as 1 and 11/12. Improper fractions can be rewritten as mixed numbers using division and remainders. To find the mixed number representation of an improper fraction, divide the numerator by the denominator. The quotient is the integer part, and the remainder becomes the numerator of the remaining fraction. Example 360. Rewriting an improper fraction as a mixed number. Rewrite 48/13 as a mixed number. Solution. When 48 is divided by 13, the result is 3 with a remainder of 9, so we can rewrite 48/13 as 3 and 9/13. Your turn, 360. Rewrite 95/26 as a mixed number. Video. Converting an improper fraction to a mixed number using Desmos. Similarly, we can convert a mixed number into an improper fraction. To do so, first convert the whole number part to a fraction by writing the whole number as itself divided by 1, and then add the two fractions. Alternately, we can multiply the whole number part and the denominator of the fractional part. Next, add that product to the numerator. Finally, express the number as that product divided by the denominator. Example 361. Rewriting a mixed number as an improper fraction. Rewrite 5 and 4/9 as an improper fraction. Solution. Step 1. Multiply the integer part 5 by the denominator 9, which gives 5 times 9 equals 45. Step 2. Add that product to the numerator, which gives 45 plus 4 equals 49. Step 3. Write the number as the sum, 49, divided by the denominator, 9, which gives 49/9. Your turn, 361. Rewrite 9 and 5/14 as an improper fraction. Tech check. Using Desmos to rewrite a mixed number as an improper fraction, Desmos can be used to convert from a mixed number to an improper fraction. To do so, we use the idea that a mixed number such as 5 and 6/11 is another way to represent 5 plus 6/11. If 5 plus 6/11 is entered in Desmos, the result is the decimal form of the number. However, clicking the fraction button to the left will convert the decimal to an improper fraction, 61/11. As an added bonus, Desmos will automatically reduce the fraction to lowest terms. Converting rational numbers between decimal and fraction forms. Understanding what decimals represent is needed before addressing conversions between the fractional form of a number and its decimal form, or writing a number in decimal notation. the decimal number 4.557 is equal to 4 and 557 thousandths. The decimal portion, 0.557, is 557 divided by 1,000. To write any decimal portion of a number expressed as a terminating decimal, divide the decimal number by 10, raised to the power equal to the number of decimal digits. Since there were 3 decimal digits in 4.557, we divided 557 by 10 cubed, equals 1,000. Decimal representations may be very long. It is convenient to round off the decimal form of the same number, or of the number, to a certain number of decimal digits. To round off the decimal form of a number to n decimal digits, examine the n plus 1st decimal digit. If that digit is 0, 1, 2, 3, 4, the number is rounded off by writing the number to the nth decimal digit and no further. If the n plus 1st decimal digit is 5, 6, 7, 8, or 9, the number is rounded off by writing the number to the nth digit, then replacing the nth digit by one more than the nth digit. Example 362. Rounding off a number in decimal form to 3 digits. Round 5.67849 to 3 decimal digits. Solution. The third decimal digit is 8. The digit following the 8 is 4. When the digit is 4, we write the number only to the third digit. So 5.67849 rounded off to 3 decimal places is 5.678. Your turn 3.62. Round 5.1082 to 3 decimal places. Example 363. Rounding off a number in decimal form to 4 digits. Round 45.11475 to 4 decimal digits. Solution. The fourth decimal digit is 7. The digit following the 7 is 5. When the digit is 5, we write the number only to the fourth decimal digit, 45.1147. Then we replace the fourth decimal digit by one more than the fourth digit, which yields 45.1148. So 45.11475 rounded off to 4 decimal places is 45.1148. Your turn 363. Round 18.6298 to 2 decimal places. To convert a rational number in fraction form to decimal form, use your calculator to perform the division. Example 364. Converting a rational number in fraction form to decimal form. Convert 47/25 into decimal form. Using a calculator to divide, solution. Using a calculator to divide 47 by 25, the result is 1.88. Your turn 364. 1. Convert 48/30 into decimal form. Converting a terminating decimal to the fractional form may be done in the following way. Step 1. Count the number of digits in the decimal part of the number labeled n. Step 2. Raise 10 to the nth power. Step 3. Rewrite the number without the decimal. Step 4. The fractional form is the number from step 3 divided by the result from step 2. This process works due to what decimals represent and how we work with mixed numbers. For example, we can convert the number 7.4536 to fractional form. The decimal part of the number, the 0.4536 part of 7.4536, has 4 digits. By the definition of decimal notation, the decimal portion represents 4,536 divided by 10 to the 4th power equals 4,536 divided by 10,000. The decimal number 7.4536 is equal to the improper fraction 7 and 4,536 10,000ths. Adding those to fractions yields 74,536 10,000ths. Example 365. Converting from decimal form to fraction form with terminating decimals. Convert 3.2117 to fraction form. Solution. 1. There are 4 digits after the decimal point, so n equals 4. Step 2. Raise 10 to the 4th power. 10 to the 4 equals 10,000. Step 3. When we remove the decimal point, we have 32,117. Step 4. The fraction has as its numerator the result from step 3 and as its denominator the result from step 2, which is the fraction 32,117. I'm talking way too fast. 32,117 10,000ths. Your turn 365. Convert 17.03347 to fraction form. The process is different when converting from the decimal form to a rational number into fraction form when the decimal form is a repeating decimal. This process is not covered in this text. Dang it. It's like stuck right there. That's going to stress me out. There we go. Got it. Sorry. Example 366. Multiplying rational numbers. Calculate 12 25ths times 10 21sts. Solution. Multiply the numerators and place that in the numerator, and then multiply the denominators and place that in the denominator. So 12 25ths times 10 21sts equals 12 times 10 divided by 25 times 21 equals 120 5 25ths. This is not in lowest term, so this needs to be reduced. The GCD of 120 and 525 is 15. 120 5 25ths equals 15 times 8 divided by 15 times 35. 15's cancel, you get 8 35ths. Your turn 3.66. Calculate 45 88ths times 28 75ths. Video, multiplying fractions. As with multiplication, division of rational numbers can be done using a calculator. Example 367. Dividing decimals with a calculator. Calculate 3.45 divided by 2.341 using a calculator. Round to 3 decimal places if necessary. Solution. Using a calculator, we obtain 1.473729175565997. Rounding to 3 decimal places, we have 1.474. Your turn 3.67. Calculate 45.63 divided by 17.13 using a calculator. Round to 3 decimal places if necessary. Before discussing division of fractions without a calculator, we should look at the reciprocal of a number. The reciprocal of a number is 1 divided by the number. For a fraction, the reciprocal is the fraction formed by switching the numerator and denominator. For the fraction a over b, the reciprocal is b over a. An important feature for a number and its reciprocal is that their product is 1. When dividing 2 fractions by hand, find the reciprocal of the divisor, the number that is being divided into the other number. Next, replace the divisor by its reciprocal and change the division into multiplication. Then perform the multiplication. Symbolically, b over a divided by c over d equals a over b times d over c, which equals a times d over b times c. As before, reduced to lowest terms. Formula. If b, c, and d are non-zero integers, then b divided by a divided by c divided by d equals a divided by b times d divided by c, which equals a times d divided by b times c. Example 368. Dividing rational numbers. 1. Calculate 4 21ths divided by 6 35ths. 2. Calculate 1/8 divided by 5 28ths. Solution. 1. Step 1. Find the reciprocal of the number being divided by 6 35ths. The reciprocal of that is 35 sixths. Step 2. Multiply the first fraction by that reciprocal. So 41 21ths divided by 61 35ths equals 4 21ths times 35 sixths. Uh-oh. They screwed that up. So in the formula, edit, it should be a over b divided by c over d equals a over b times d over c. Yeah, that didn't make sense to me. I just was kind of reading without seeing the error. But yeah, that's an error. Yeah, so keep that. So 421 times 35 sixths equals 140 126. The answer 140 126 is not in lowest terms. The GCD of 140 and 126 is 14. Factoring and canceling gives 140 126, which equals 14 times 10 divided by 14 times 9. 14's cancel. You get 10 ninths. 2. Step 1. Find the reciprocal of the number being divided by, which is 5 28ths. The reciprocal of that is 28 fifths. Step 2. Multiply the first fraction by that reciprocal. 1/8 divided by 5 28ths equals 1/8 times 28 fifths equals 28 40th. The answer 28 40th is not in lowest reduced form. The GCD of 28 and 40 is 4. Factoring and canceling gives 28 40ths equals 4 times 7 divided by 4 times 10. 4's cancel, you get 7 tenths. Your turn 3.68. 1. Calculate 46 divided by 175 divided by 69 69 over 285. 2. Calculate 3/40ths divided by 42 55ths. Video. Dividing fractions. Applying the order of operations to simplify expressions. The order of operations for rational numbers is the same as for integers, as discussed in order of operations. The order of operations makes it easier for anyone to correctly calculate and represent. The order follows the well-known acronym PEMDAS. So P, parentheses, E, exponents, MD, multiplication, division, AS, addition, subtraction. The first step in calculating using the order of operations is to perform operations inside the parentheses. Moving down the list, next perform all exponent operations moving from left to right. Next, left to right once more. Perform all multiplications and divisions. Finally, perform the additions and subtractions. Example 369. Applying the order of operations with rational numbers. Correctly apply the rules for the order of operations to accurately compute parentheses 5/7 minus 2/7 close times 2 to the third power. Solution. Step 1. To calculate this, perform all calculations within the parentheses before other operations. So we have parentheses 5/7 minus 2/7 close times 2 to the third power equals 3/7 times 2 to the third power. Step 2. Since all parentheses have been cleared, we moved left to right and compute all the exponents next. So we have 3/7 times 2 to the third power equals 3/7 times 8. Step 3. Now perform all multiplications and divisions, moving left to right. 3/7 times 8 equals 24/7. Okay, your turn, 369. Correctly apply the rules for the order of operations to accurately compute parentheses 3/16 plus 7/16 close squared plus 1/5 divided by 3/10. Example 370. Applying the order of operations with rational numbers. Correctly apply the rules for the order of operations to accurately compute 4 plus 2/3 divided by parentheses 5 divided by 5/9 close squared minus parentheses 2/3 plus 5 close squared. Solution. To calculate this, perform all calculations within the parentheses before other operations. Evaluate the innermost parentheses first. We can work to separate parentheses expressions at the same time. Step 1. The innermost parentheses contains 2/3 plus 5. Calculate that first, dividing after finding the common denominator. So 4 plus 2/3 divided by parentheses 5/9 close squared minus parentheses 2/3 plus 5 close squared equals 4 plus 2/3 divided by parentheses 5/9 close squared minus parentheses 2/3 plus 5/1 close squared, which equals 4 plus 2/3 divided by parentheses 5/9 close squared minus parentheses 2/3 plus 15/3 close squared equals 4 plus 2/3 plus parentheses 5/9 close squared minus parentheses 17/3 close squared. Step 2, calculate the exponents in the parentheses. So we have parentheses 5/9 close squared. Okay, so we have 4 plus 2/3 divided by parentheses 5/9 close squared minus parentheses 17/3 close squared equals 4 plus 2/3 divided by parentheses 25 81st close minus parentheses 17/3 close squared. Step 3. Subtract inside the parentheses is done using a common denominator. 4 plus 2/3 divided by parentheses 25 81st close minus parentheses 17/3 close squared. 4 plus 2/3 equals parentheses 25 81st close minus parentheses 17 times 27 divided by 3 times 27. 27's. So we're making common denominator. Close squared. 4 plus 2/3 divided by parentheses, 25/81, close, minus parentheses, 459/81, close, squared. And then 4 plus 2/3 divided by parentheses, negative 434/81, close, squared. Step 4, at this point, evaluate the exponent and divide. So we have 4 plus 2/3 divided by parentheses, negative 434/81, close, squared. That equals 4 plus 2/3 divided by parentheses, 188,356, 6,561, close, equals 4 plus 2/3 times 6,561, 188,356 equals 4 plus 2,187, 94,178. Step 5, add 4 plus 2187 over 94,178 equals 378,889 divided over 94,178. Had this been done with the calculator, the decimal form of the answer would be 4.0232, rounded to 4 decimal places. Your turn 370. Correctly apply the rules for the order of operations to accurately compute. So 3/5 plus 2, parentheses, 3/5 plus 2, close, times, parentheses, 4/5 minus a half, close, squared, divided by 11/15. Video, order of operations using fractions. Applying the density property of rational numbers. Between any two rational numbers, there is another rational number. This is called the density property of the rational numbers. Finding a rational number between any two rational numbers is very straightforward. Step 1, add the two rational numbers. Step 2, divide that result by 2. The result is always a rational number. This follows what we know about rational numbers. If two fractions are added, then the result is a fraction. When a fraction is divided by a fraction, and 2 is a fraction, then we get another fraction. This two-step process will give a rational number, provided the first two numbers were rational. Example 371. Applying the density property of rational numbers. Demonstrate the density property of rational numbers by finding a rational number between 4/11 and 7/12. Solution. To find a rational number between 4/11 and 7/12, add the fractions. So we have 4/11 plus 7/12 equals 4 times 12 divided by 11 times 12 equals, 4 times 12 over 11 times 12 plus 7 times 11 over 12 times 11 equals 48/132 plus 77/132 equals 125/132. Step 2, divide the result by 2. Recall that to divide by 2, you simply multiply by the reciprocal of 2. The reciprocal of 2 is 1/2, as seen below. So 125/132 divided by 2 equals 125/132 times 1/2 equals 125 divided by 264. So one rational number between 4/11 and 7/12 is 125/264. We could check that the number we found is between the other two by finding the decimal representation of the numbers. Using a calculator, the decimal representations of the rational numbers are 0.363636 ... 0.47348848 ... and 0.583333 ... Here it is clear that 125/264 is between 4/11 and 7/12. Your turn 371. Demonstrate the density property of rational numbers by finding a rational number between 27/13 and 21/10. Solving problems involving rational numbers. Rational numbers are used in many situations, sometimes to express a portion of a whole, other times as an expression of a ratio between two quantities. For the sciences, converting between units is done using rational numbers, as when converting between gallons and cubic inches. In chemistry, mixing a solution with a given concentration of a chemical per unit volume can be solved with rational numbers. In demographics, rational numbers are used to describe the distribution of the population. In dietetics, rational numbers are used to express the appropriate amount of a given ingredient to include in a recipe. As discussed, the application of rational numbers crosses many disciplines. Example 372. Mixing soil for vegetables. James is mixing soil for a raised garden in which he plans to grow a variety of vegetables. For the soil to be suitable, he determines that 2/5 of the soil can be topsoil, but 2/5 need to be peat moss and 1/5 has to be compost. To fill the raised garden bed with 60 cubic feet of soil, how much of each component does James needs to use? Solution. In this example, we know the proportion of each component to mix, and we know the total amount of the mix we need. In this kind of situation, we need to determine the appropriate amount of each component to include in the mixture. For each component of the mixture, multiply 60 cubic feet, which is the total volume of the mixture we want, by the fraction required of the component. Step 1. The required fraction of the topsoil is 2/5, so James needs 60 times 2/5 cubic feet of topsoil. Performing the multiplication, James needs 60 times 2/5 equals 125, which equals 24. Found by treating the fraction as division, and 120 divided by 5 is 24 cubic feet of topsoil. Step 2. The required fraction of peat moss is also 2/5, so he also needs 60 times 2/5 cubic feet, or 60 times 2/5 equals 125 equals 24 cubic feet of peat moss. Step 3. The required fraction of compost is 1/5. For the compost, he needs 60 times 1/5 equals 65 equals 12 cubic feet. Your turn 372. Ashley wants to study for 10 hours over the weekend. She plans to spend half the time studying math, a quarter of the time studying history, an eighth of the time studying writing, and the remaining eighth of the time studying physics. How much time will Ashley spend on each of these subjects? Example 373. Determining the number of specialty pizzas at Bella's Pizza. 1/3 of the pizzas that are ordered are one of the specialty pizzas. If there are 273 pizzas ordered, how many were specialty pizzas? Solution. 1/3 of the whole are specialty pizzas, so we need 1/3 of 273, which gives 1/3 times 273 equals 273 thirds, which equals 91, found by dividing 273 by 3. So 91 of the pizzas that were ordered were specialty pizzas. Your turn 373. Danny, a nutritionist, is designing a diet for her client Callum. Danny determines that Callum's diet should be 30% protein. If Callum consumes 2,400 calories per day, how many calories of protein should Danny tell Callum to consume? Video. Finding a fraction of the total. Using fractions to convert between units. A common application of fractions is called unit conversions, or converting units, which is the process of changing from the units used in making a measurement to different units of measurement. For instance, 1 inch is approximately equal to 2.54 centimeters. To convert between units, the two equivalent values are made into a fraction. To convert from the first type of unit to the second type, the fraction has the second unit as the numerator and the first unit as the denominator. From the inches and centimeters example, to change from inches to centimeters, we use the fraction 2.5 centimeters per inch. If, on the other hand, we wanted to convert from centimeters to inches, we use the fraction 1 inch to over 2.54 centimeters. This fraction is multiplied by the number of units of the type you are converting from, which means the units of the denominator are the same as the units being multiplied. Example 374. Converting liters to gallons. It is known that 1 liter is 0.264172 gallons. So use this to convert 14 liters into gallons. Solution. We know that 1 liter equals 0.264172 gallons. Since we are converting from liters, when we create the fraction we use, we make sure the liter part of the equivalence is in the denominator. So to convert the 14 liters to gallons, we multiply 14 by 1 gallon over 0.264172 gallons per 1 liter. Notice that the gallon part is in the numerator since we are converting to gallons, and the liter part is in the denominator since we are converting from liters. Performing this and rounding to 3 decimal places, we find that 14 liters is 14 liter times 0.264172 gallons divided by 1 liter equals 3.69841 gallons. Your turn 3.74. 1 mile is equal to 1.60934 kilometers. Convert 200 miles to kilometers. Round off the answer to 3 decimal places. All right, that's about another 30 minutes. That's the end of part 2.